In one of India's poorest regions, a group of young engineers came up with an idea so bold that even Americans would tip their hats: building roads from coconut waste. It sounds unbelievable, but it's completely real. Using discarded coconut husks, they've created durable, eco-friendly roads that are changing entire communities. So what secret are these Indian innovators hiding behind this remarkable process? Let's dive in and uncover it together with Mandarin Tech. In the southern states of India, where a tropical climate lasts all year, people endure heavy rainfall during two back-to-back monsoon seasons, followed immediately by scorching summer heat. This harsh weather cycle causes local roads to deteriorate quickly. The soil base is heavily eroded by monsoon runoff, while the road surface cracks and breaks apart from constant expansion and contraction under the summer heat. Facing this challenge, local engineers realized that coconut fiber, well known for its tensile strength and natural resistance to decay, could be an ideal material for stabilizing soil and preventing erosion. That insight led to the creation of coconut fiber geotextiles, a breakthrough solution for building sustainable, low-cost, and environmentally friendly roads. This 100% natural fabric, woven entirely from coconut fibers, locks the soil in place, spreads out compressive loads, and protects the ground from erosion during the rainy season, while still allowing water to pass through naturally, preserving the soil structure and maintaining the environmental balance. And of course, to produce coconut fiber geotextiles, everything starts with the coconuts themselves. Southern India is the country's true coconut capital, with more than 19 billion coconuts harvested each year. The different parts of the coconut are used for all kinds of purposes. The coconut water is bottled for drinking, the white flesh is processed into flour or pressed into coconut oil, and even the byproducts are turned into food ingredients. We'll explore those uses later, but for now we're going to focus on the part that matters for our story: turning coconut husks into coconut fiber geotextile fabric. Coconuts are usually harvested 1 year after they first form, when the husk has matured enough for fiber extraction. Skilled workers climb coconut palms as tall as 10 meters without ropes or any kind of safety gear. With nothing but a machete in hand, they cut entire clusters and let them fall freely to the ground, where each coconut can weigh more than 3 kilos. However, this method isn't always safe or efficient. In difficult terrain or with palms that are too tall, workers use long poles, sometimes up to 10 meters, to cut the coconuts from the ground. While this keeps the harvester safe, the coconuts fall with force and can hit rocks or exposed roots, cracking the shell and seriously affecting their quality. After harvesting, the coconuts are transported to a collection point where the dehusking process begins. Next, the coconuts are split open and the husk is separated from the shell using a sharp wooden or metal spike. A skilled worker can husk anywhere from 500 to 1,000 coconuts a day, depending on size and moisture levels. The fibrous husk makes up about 35–45% of the coconut's total weight, and it's this layer that contains the valuable coir fibers. The coconut husks are loaded onto trucks and transported to a nearby processing facility. There, they're dumped into an open yard for storage, and on average the facility processes up to 2 tons of coir every day. The coconut husks are spread out and left to dry under natural sunlight for 2 to 4 weeks, depending on the season. This drying stage reduces moisture from around 65% down to about 15%, softening the husk and making it easier to separate the coir fibers. Massive piles of dried coconut husks are gathered by heavy loaders, which scoop them up and transfer them into large transport bins to begin the processing stage. The collected husks are then dumped into a feeding hopper that directs them toward the conveyor system. A conveyor belt carries the material into the decortication unit at a steady, controlled rate, ensuring continuous flow for efficient separation. Inside the decorticator, rotating blades and tearing rollers break the husks apart and release the coir fibers, which spill out in loose, tangled bundles as the inner pith and shell fragments are removed. The separated fibers then enter a rotary drum sieve that filters out dust and fine particles, leaving only clean, long strands. The coir fibers are then taken outdoors and spread under the sun to dry for 3 to 7 days, depending on the weather. During this stage, the moisture level drops from around 15% to below 5%, stabilizing the fibers. This final drying ensures the coir becomes lighter, cleaner, and ready to transport to weaving facilities. After that, the coir fibers are moved to a pre-twisting section, where spinning machines run continuously to form consistent, stable fiber bundles, with a capacity of up to about 3 tons of fiber per day. Here, the fibers are loosened and sorted by length, then twisted into uniform strands with reliable tensile strength so they won't break or tangle during the geotextile weaving process. Depending on product requirements, the fibers can also be refined into thinner and softer strands to match different loom types and weaving densities. Once prepared, the bundles are rolled, tied, and sent to the weaving area, where they are turned into coir geotextile fabric used for soil reinforcement, erosion control, and natural drainage. When the bundles of coir fiber are brought to the weaving area, they're wound onto large spools and fed into the loom to begin forming the fabric. The longitudinal strands are stretched tightly in parallel rows, creating the warp system that forms the structural backbone of the geotextile sheet. Next, the cross strands are woven through using guide needles and bars, forming the strong interlocking pattern characteristic of coir geotextiles. The loom moves in a steady rhythm, placing each layer of fiber precisely and maintaining consistent mesh spacing to optimize drainage and soil retention. With every pass, the fabric gradually takes shape with a coarse, natural texture but high tensile strength, making it suitable for soil reinforcement and erosion control. Once weaving is complete, the rolls are inspected for uniformity, thickness, and knot integrity to ensure they meet field-grade construction standards. Finally, the fabric is rolled into large coils, ready to be transported to road projects, slope stabilization sites, or land restoration areas. On average, 100 kilograms of coir fiber can produce around 250 to 300 meters of geotextile fabric at a 1-meter width, with costs ranging from $1.20 to $1.80 per meter, depending on thickness and weave density. The coir geotextile rolls are loaded onto trucks and transported to the construction area. Once on site, they are unloaded either manually or with lifting equipment, depending on the size and length of the rolls. Moving large continuous rolls helps the installation process run smoothly without needing multiple seams or overlaps. Next, road rollers are used to compact and smooth the soil surface, removing bumps, loose material, and uneven spots along the alignment. This creates a firm, level base that ensures the coir geotextile can be laid flat without wrinkles or gaps. At the worksite, the rolls are positioned at the start of the road and pulled along the alignment by the construction crew. The workers carefully unroll the coir geotextile over the leveled soil, making sure it stays straight and fully in contact with the ground. Workers secure the fabric in place using stakes, pins, or steel anchors to prevent shifting during the next construction stages. Proper alignment and a smooth, wrinkle-free surface ensure optimal drainage, soil retention, and even load distribution. The coir geotextile helps stabilize the soil underneath by holding soil particles in place, especially during heavy rain. Its natural woven structure spreads pressure and reduces localized sinking on weak or unstable ground. This makes it especially suitable for slopes, riverbanks, soft soil areas, and regions prone to erosion. Once the fabric is secured, a layer of gravel is spread on top to form a load-bearing surface. This helps lock the geotextile in place and distributes weight evenly before the soil layer is added. A road roller follows right behind to compact the surface and create a smooth, stable base, which is typically about 10 to 15 centimeters thick, ensuring it becomes firm enough to support the final road surface. This is followed by a layer of soil, creating a uniform base while protecting the geotextile from direct pressure. After that, an additional layer of coarse crushed stone is spread across the roadbed to increase bearing strength and improve drainage. A road roller then compacts this layer, locking the stones into place and creating a firm foundation ready for the final paving stage. When the base is stabilized, the remaining steps are similar to building a standard asphalt road. Asphalt is spread evenly, compacted in multiple passes, and finished to meet smoothness and density requirements. The result is a road that looks like this, transformed into a more durable road, less cracked and with a longer lifespan, even in harsh climate conditions. So that wraps up this fascinating road building process. But the video isn't over yet. Like I mentioned at the beginning, coconuts have many other surprising uses, and we're going to explore more coconut-based processes next. Stick around, it's definitely not going to disappoint you. Coconut water is a refreshing drink that people all around the world have tasted at least once. However, because fresh coconut water is difficult to transport and store, it is also processed and packaged to extend its shelf life and make distribution easier. Once inside the processing facility, the coconuts are fed into an automated system where a precise drill creates a small opening in the hard shell to extract the liquid inside. After being removed from the coconut, the water is transferred into a cooling tank with a capacity of up to 1,000 liters, where the temperature is lowered to 4 degrees Celsius to preserve its nutrients. It then passes through a filtration system that removes impurities, residue, and oils. Finally, the coconut water is briefly sterilized to eliminate bacteria and cooled again, keeping its original freshness and nutritional value intact. Finally, the coconut water, now sterilized and chilled, moves to a modern packaging line. There it's filled into pre-sterilized multi-layer cartons that protect the product from light and air, helping extend its shelf life. This fully automated line is highly accurate and efficient, with a capacity of up to 6,000 cartons per hour. Thanks to this process, the coconut water stays fresh and ready for large-scale distribution. While coconut water becomes a refreshing natural drink, the coconut meat takes a different path into the world of health and beauty. Once the tough brown shell is removed, the soft, creamy white flesh is collected. This flesh is carefully pressed to extract precious coconut oil, a true gift from nature, rich in nutrients. This oil nourishes hair, softens skin, and supports wellness from the inside out. After being cut into small pieces, the coconut meat is transferred into an automatic washing system, where powerful jets of high-pressure water completely remove dirt, sand, and any remaining impurities. Some factories even use warm water or mild disinfectant solutions for a more effective cleaning process. Next, the coconut meat is moved to the grinding and pressing stage. The cleaned coconut pieces are fed into a grinder, where sharp blades spin at high speed to turn them into a smooth mixture. This mixture is then transferred to a mechanical or cold pressing machine, where strong compression separates the oil from the coconut fiber. This process helps preserve the natural aroma and ensures a high level of purity, preparing the oil for the next filtration step. After being carefully pressed and filtered, the pure coconut oil is moved to the packaging area. An automated filling system measures and dispenses the oil precisely into each glass jar or plastic bottle, ensuring hygiene and consistency. The bottles are then sealed and labeled. The entire process takes place in a sterile environment to maintain the oil's quality and natural fragrance for a longer shelf life. The coconut meat is also finely ground to produce coconut milk, a nutrient-rich plant-based milk that is creamy, smooth, and naturally aromatic. This grinding and extraction process is carried out immediately after harvesting to retain maximum freshness. After grinding, the coconut pulp is cooked at a temperature of around 60 to 70 degrees Celsius for 30 to 45 minutes. This allows the oil to rise to the surface and eliminates bacteria, serving as an important step to ensure the quality of the final product. Once the fats have been separated, the soft and velvety coconut milk is transferred to a fully automated packaging line. Clean cans are passed through a sterilization chamber at temperatures above 120 degrees to remove all bacteria. The coconut milk is then carefully filled into each can, and the lids are sealed within seconds. This process ensures a safe, long-lasting, high-quality product. A single factory can process up to 2,000 cans of coconut milk per hour. The cans of coconut milk are then passed through a high-pressure processing system, a technology that uses extremely high pressure of up to 600 MPa to eliminate bacteria without heat. Thanks to this method, the product retains its natural flavor, color, and nutrients much longer than with traditional thermal sterilization. Next, a system neatly arranges the cans into cartons with about 24 cans in each box. The cartons are sealed and labeled with barcodes for easy traceability. This ensures the product is ready to leave the factory and be distributed to supermarkets and dining tables of consumers around the world. Alongside coconut milk, the coconut meat continues its transformation into a colorful traditional sweet. The white coconut flesh is sliced into thin strands measuring about 2 to 3 millimeters thick. After being shredded, the coconut is rinsed with warm water to reduce oil and its natural aroma, then drained and cooked with sugar over medium heat. This cooking process lasts 45–60 minutes, allowing the sugar to absorb without breaking the strands. Finally, the candied coconut is dried at 60 to 70 degrees to extend its shelf life while preserving its softness and signature coconut fragrance. After drying, the candied coconut is transferred to the packaging area, where it is evenly portioned and placed into zip bags or sealed plastic pouches in a clean, dry environment. Each bag is heat-sealed and labeled with its weight, production date, and expiration date to ensure food safety. And so, the coconut's remarkable journey comes to an end. From roads reinforced with Coir Geotextile fibers to practical products used in everyday life. From sustainable construction materials to food, health, and beauty, the coconut proves that no part of it is ever wasted. See you in the next video, where Mandarin Tech continues to explore the processes that turn the ordinary into the extraordinary.